This video is the first part of a two-part series going through some general tips and tricks for Alibre Atom 3D, and these are also relevant to Alibre Design Professional and Alibre Design Expert. This is to accompany the articles that are going to be released in the May and June editions of Model Engineers Workshop. I am providing timestamps in the video description, so if you'd like to go to a specific tip, then you can just pick the thing you're interested in and jump straight to it. Hope you find this useful, and let's get into it. So the first thing I wanted to cover is just as a general bit of CAD modeling advice is how you decide whether something should be an individual part or created as an assembly of multiple components. And the best way I can describe this is, in general, I would work on the philosophy of how the part in question is going to be manufactured. So in this case here, I've got a little custom kickboard clip. Now this is actually made as two pieces, this piece here, and then there's a separate base that allows it to be adjustable. So on that basis, I would 3D print this. This is a single component, so that is all the detail that goes in the part. Now I could also model the base component in the same part file, but then that wouldn't give me the ability to manufacture them as two individual components. So that's why the two pieces should be modeled as separate parts, and then we can use the assembly to put them together. And then just an example, that's the part on its own. And then I can just quickly open it up. This is the assembly of the two components together, so that I can independently send those as 3D printing files for manufacturer, and then we can look at how they combine together in the assembly workspace. So as a rule of thumb, if you're not sure whether something should be an individual component or an assembly, is really just to consider how you would actually go about making it. So even sometimes parts that would ultimately be fixed together, if you're interested in actually making them, a good example might be a welded assembly, you would still need to cut the individual pieces of the assembly out as separate pieces. So I would create the model to reflect that. So you make the individual parts and then use the assembly workspace to put them together. Now the one caveat for that is that sometimes if you're using something as reference, if you're buying in, say, a welded assembly of bits, and you would only ever be working with it in its welded form, then you may be able to take the shortcut of just modeling that as a component, on the basis that you don't need the added detail of sort of how it goes together. But for anything you're designing to make yourself, then follow the process of how you would actually go about making it. Now the next tip that we cover is just sort of some points on how to manage the 3D view. Now the standard view controls in Alibre and sort of most CAD packages are fairly similar. You'll have the ability to rotate the view, zoom in and out using mouse controls. However, what you tend to find is when you're modeling, or particularly when working in the assembly workspace, you end up having to sort of zoom in to select fine details, and it can sometimes become quite confusing as to what part of the model you're looking at. So in Alibre, what I recommend doing is making sure that the view cube is turned on. So in this case, we can just jump onto the view tab and then make sure the toggle view cube button is turned on, and that just creates this little cube top right here that shows the orientation. But also we can click on any individual face or corner, and the software will automatically orient to the selected view and zoom out to fit the whole model. So for example, if I click on the left view, I'm going to zoom out and center looking at it from the left, or if I want a sort of 3/4 view, I could pick one of the corners. And that just means no matter what funny zoomed in weird view I've got, I can very quickly jump into something that I can see the overall model and get my bearings back. So particularly when you're starting out, that's a real sort of get out of jail free card on your view. So the other thing I wanted to just go through on this one, I'm just going to close this model down and the part we had open and just jump back to the Alibre home window. Something else that I'd just like to point out to people is the Alibre has some absolutely first-rate scaling and visual setting options. And there's a few people I've spoken to who have, you know, less than perfect eyesight, or some couple of guys who've working with the software who suffer from red green colour blindness, and so some of the default colours or some of the sizes of things in its out the box settings might be a little bit suboptimal view wise. So we can go into system options, and I'll just go to this section. So the first one that's worth looking at is the design tree settings here under all workspaces, and we can adjust the size of the tree. So by default I've got it on small, so if I change this up to medium, for example, go OK, and then I'm just going to jump back into the part we had open before, and you can now see that the tree on the left has been scaled up, which makes it a lot more readable. The other thing to note is that we can also scale the menu at the top, but the ribbon menu follows the Windows display scaling setting, so you know that should be scaled to a suitable level based on what you've got your monitor settings set to already. But because this Design Explorer on the left is sort of specific to this bit of software, Alibre have included dedicated settings to change the scaling of that. The other thing that's useful, I'm going to go back to the Utility tab and Systems options, and then we can go down, and the very last option here under Display is Color Scheme. Now under here we can change the colors for all of the UI and display settings. So the default scheme is generally good, but again, if you were to say have red green color blindness, it does feature red and green in quite a few places. So I worked with a client recently, and we created a custom set scheme, and there's some notes on the Model Engineers Workshop forum over the exact settings we've used for that, and I can paste up a screenshot of the settings that we used through here, which can just run through the various sections and change the colors as needed. I've also been made aware that Alibre have been looking into this based on the feedback we gave them, and I think coming in the version 29 update cycle, I don't know if it'll be the initial release or a point update, but version 29 should be including a scheme aimed specifically at red green color blindness. So hopefully I will probably post an update about that when we know more. But if I go on to the no red green theme we've set up there, and then jump back into the same part, and now you can see that we're using different background colors. The profile sketches are now in blue rather than red, and if I jump into sketch, we're using blue, orange and black for the degrees of freedom colors rather than red, yellow and black. So again, this is just to avoid using colors that would potentially cause someone difficulty with that specific condition. So I'll close this part down. The next set of tips are focused on just some general advice on part modeling. So here I've got a very simple example part, a little L-shaped block. So my first bit of advice is it's a good idea to work around center. So when you start a new part, Alibre gives us an origin point, which is in there. So if I just jump into the sketch we've created here, and what I've done is I've used that as my starting point and worked around that as a center. So I've got this part dead center on there. The other thing I've done as well is that when I've then used this to create an extrusion, instead of extruding one side of the plane, I've used the mid plane command, and that will create the distance I specify equally around the plane. Now the advantage for doing this is that this means that I've got planes running through the center of the part on all three axes. Now the reason this is desirable is it means that, for example, if I was to create a feature on this face here that has a corresponding feature on the other side, I can just create the feature and then I can mirror around the XY plane to duplicate it on the other side of the part. Now, had I not built the part in the center, I would still be able to do it, but I would have to manually create a reference plane. So by working around a center, you give yourself this sort of shortcut to getting to using tools like mirror. It also can be particularly handy when working in assemblies, because it's quite common when you're designing parts that you need to center them in relation to each other. So by having planes running through the middle, you can actually use the part modeling reference planes as an alignment feature within the assembly workspace. So I think working from round centers is generally good advice for part modeling. The only situation I can think of where that might not be what you want to do is there is a couple of different CNC tools available for Alibre, and in one of them in particular, I believe the Mechsoft CNC plugin integrates directly into the Alibre workspace. Generally, CNC machines are set up with 000 being the start coordinate, and then they expect cutting coordinates to be positive x, positive y, positive z, which would be this sort of quadrant in the top right corner here from this view. So if you were driving a CNC toolpath from your parts, you can make your life a little bit easier by modeling in the plus x, plus y, plus z quadrant to avoid negative values, although I believe the Mechsoft plugin does allow you to reposition the origin point to avoid that being a problem, but just something to be aware of. But generally, as a sort of just modeling advice, working around centers is a good idea. The next tip I wanted to run through was, well, as I've said in the article, is to be lazy. So one mistake I see people who are newer to CAD tools making is the fact that where you've got, say, a repeated feature, for example, they will go through and create planes and sketches for every single feature and end up duplicating a lot of work. And apart from the fact that that takes longer, it also makes it quite difficult to sort of update and iterate in your design. If you create a set of 4 ribs and you've got a separate sketch for 4, you're going to need to go through and update all the sketches to make a change. So if you know that you're designing something that should be a feature that should be common but is repeated, what I'd recommend doing is creating one and then using things like the mirror or the pattern tools to copy it to where it needs to go. So for example, on this block here, I've got an example little rib feature we've created there. So that's just quite a simple little 2mm thick 20 by 20 rib, and I'd like a series of 4 of them along this edge. So instead of modeling the rib 4 times, I can just use a linear pattern feature here, and with that I just select the feature we've created, select an edge, and then work out a spacing. And in this case, the way you can also type little formulas in. So in the spacing box, we can select the edge here. Alibre tells us that's 98mm. I know I want 4 instances, but there is 3 gaps. So if I do 98/3, that gives me the correct spacing to position all 4 along the length there. And then click OK. And that copies those features in, and that has the advantage of, one, there's a lot less modelling, so it's quicker. But also, if I now decide that this rib needs to be slightly bigger, so if I go back and edit the rib sketch, and let's say we're going to make it 23 mil, 23, so that updates. But thanks to using a pattern, all I do is just drag the dog bone, as they call it, down in the tree to re-enable the pattern feature, and all the subsequent instances of it update. So strongly recommend using patterns, circular patterns or mirror, wherever possible if you've got repeating features. The final tip on general tip on part modeling is to do with working with thin wall parts. So this at the moment is a solid block. That is the way I would recommend working with something, is to work with it as a solid for as long as possible, and then once you've got the exterior shape and design sorted out, is then we can use the shell command to turn that into a thin wall feature. So in this case I've got a shell there, but if I just delete this and run through this again, so if we go on to shell, I need to specify faces to remove, and I need to give it a thickness. So let's say we're going to make this 2 mil thick. Now on faces to remove, I could leave that blank. So if I do that, that now makes the part hollow, but without having any open faces. Now if I just jump into inspect, we can go into, say, an XY section view, and you can see that we're open inside. That can be useful if, for example, you were planning on 3D printing this. If you leave it solid, then the 3D printer is going to fill the full volume. Probably most slicers will put in a sort of reduced density fill. However, if you make it thin walled, then the slicer should use just minimal support material, so you can actually save quite a lot of material if you don't need the part to be sort of solid all the way through. The other thing though, in this case, this part I want it to be an open shell, sort of like a casing. So if I just go back into my shell command and I'm going to set this bottom face to be open and go OK, and then that will give us sort of like a plastic casing or cover, for example. It gives us an open cavity. And so if this then needed some interior details, is the way I would work, is model everything on the exterior, then apply a shell, and then we can start adding fine details on the inside. But whilst you're working with the solid, you don't have to worry about you can overlap sketches into the solid volume, and it's just going to merge together. Whereas now it's thin walled, if I was to sort of try and put a feature on an edge or a face on the side, I do have to be mindful about how deep into the part it goes before it starts coming through onto the inside, and then I'd have to do extra work to tidy that up. So as a sort of working as a solid for as long as possible generally makes your life easier. So that's everything I wanted to go through in this video. I hope you found that useful, and we're back with the second part, looking at a series of tips based on sketching, some things that might make life easier with assemblies, and then also looking at some things you may not be aware of on the drawing tools.